Hey everyone, today we are going to talk about the main reaction types that you're probably learning about in your general chemistry class. So let's start with a synthesis reaction. This is the kind of reaction where we have two or more reactants. Of course, those are the things you see on the left right there, the reactants right here, and then the products on the right side. Two or more reactants forming one product. So we have two different elements coming together to form one unique compound. So say we have carbon plus oxygen making carbon dioxide. Two things synthesizing into one. Now we have a decomposition reaction. We have one reactant which decomposes into two or more products. Say we have A and B, which is one unique compound, decomposing into A plus B, two different elements, breaking off into two different elements. Say we have table salt, NaCl, decomposing into sodium and chlorine. It's a very easy way to remember it. When you think about what the word decompose means, it just means, breaking off. So we have this one unique compound breaking off into two different elements. Now we'll talk about the single replacement reaction. That's when one element or group replaces one other one. So see here how we have A plus B and C. And then on the reactant or the product side, we have AC plus B. See how the C and the A came together. Let's take a look at an example. Zn plus CuCl2 reacting to form ZnCl2 plus copper. So let's take a look. We have Zn plus CuCl. Do you see how Zn was over here by itself and then it came together on this side, leaving copper alone? So that's your single replacement reaction. Now we'll take a look at the double replacement reaction. When two elements / groups of different compounds, that's the key, switch places. So we'll say we have a very basic reaction looking at it just with lettered placeholders. We have A and B plus C and D. And then we have AD plus CB. Do you see how there was a double switch there? How D came over from that side, and then we had D and B switching places all together. We had the double switch there. Let's take a look at an example. BaCl2 plus MgSO4 to form BaSO4 plus MgCl2. You see how on this side we have BaCl2 and then those two switch. That is what forms your double replacement reaction. Now let's move on to the neutralization reaction. This is just when acids and bases form come together to form water and a salt. And I made a note here. Remember, salts, it's not just your table salt, your NaCl, sodium chloride. It's just salts have, in chemistry anyway, salts have relative numbers of cations and anions, leaving an electrically neutral product. So there's all kinds of different salts we can have. It's not just your regular table salt that you're used to seeing. Right here in the first example, we have sodium chloride with table salt, and then we have ammonium fluoride, and then magnesium carbonate. So there's all kinds of different salts. So let's take a look at an example. We have an acid here, hydrochloric acid, and then we have Ca OH2, forming CaCl2 plus H2O. We have our acid right here, our base, and then we have our salt and our water. Now we'll take a look at combustion reactions. When fuel burns in the presence of oxygen. This is very exothermic, meaning it releases a lot of heat. So let's take a look at this. We have our hydrocarbon plus our oxygen reacting to form carbon dioxide and water. So let me preface this by saying it's not always a hydrocarbon, but typically you will see a hydrocarbon and oxygen followed by a carbon dioxide and water, especially in the basic chemistry classes, which you're probably in right now. So this is basically the formula that you want to look for. We have our hydrocarbon, which, if you don't know, is simply a compound containing carbon and hydrogen, hydrocarbon. And then we have our oxygen, so we have 5 of them. Reacting, you see fire, and we have 3 CO2 plus 4 H2O. We have our hydrocarbon right there, like I said. Then we have oxygen coming together with it, forming carbon dioxide and water. This is the general formula. If you're trying to learn about these different types of reactions and decipher between them, look for your hydrocarbon and then your carbon dioxide, and you will most likely be able to identify it just fine. But I will say, like I said earlier, it's not always a hydrocarbon. Now let's take a look at your reduction oxidation reactions, also called redox reactions. This involves the transfer of electrons from one species to another. So those electrons are going somewhere, right? So let's talk about that. As the definition says, they're transferred from within the reaction to different species inside that reaction. So the species that's giving up electrons, that's oxidized. That is the oxidized species. And the species gaining electrons are just called reduced species. And you can remember that using this very, very helpful mnemonic, oil rig. Oxygen is loss. Reduced is gain. That's very helpful, and that will help you work your way through these different redox reactions that you're looking at. And of course, usually we identify these with oxidation numbers, which I've put up here. I will make another video about oxidation numbers and how to figure that out. There's all sorts of rules that you'll want to follow, like pure elements have a 0 oxidation number, as you can see right here, and fluorine is usually -1, chlorine is usually -1 as well, and most halogens are, and typically oxygen is -2, and of course your group 1 alkali metals are +1, and group 2 alkali earth metals are typically +2, but we'll talk about that in a later video. So let's take a look at this reaction that we're seeing here. H2S is oxidized because it lost 2 electrons. If we were counting the electrons here and how they were transferred, H2S lost 2 electrons, and that formed sulfur, which we see right here. H2S donated electrons, so it's called the reducing agent. I know that's very confusing. Let's write that out here. So the species that donates, let's see, species donating electrons is the reducing agent. Because it's causing the other species to be reduced. So that's why it's called the reducing agent. It's about what it's doing to the other part of the reaction. Whereas, let's take a look at HClO here. Right, HCl is reduced. Because it accepted electrons. And that produced Cl, as we'll see right there. Thus, it would be the oxidizing agent. Species accepting electrons is the oxidizing agent, because it caused the other species to be oxidized. So let's take a look here. This is the oxidizing agent, not that per se, but HClO, whereas H2S is the reducing agent. H2S caused, let's go down here a little bit. H2S caused HClO to be reduced. And that makes it H2S caused HClO to be reduced. Therefore, it is the reducing agent. You could look at it the other way and say that HClO caused H2S to be oxidized. Therefore, it is the oxidizing agent because of what it did to H2S. And it's a little complicated at first, but when you think about it, it really makes sense because it's kind of an equilibrium. You figure it out for one thing, and then you work your way backwards and figure out which one is the oxidizing agent and which is the reducing agent, and it comes very easy over time. So that's all for today, guys. Next time, maybe we'll look through oxidation numbers and how to figure those out. Thank you.